All right, this next lesson is called coordinate proofs. All right, this first definition is coordinate proof, okay? A coordinate proof is an algebraic proof of a geometric theorem, okay? Coordinate proof. Now, there's a couple formulas you're going to need to know for this lesson, okay? The first one you need to know is the slope formula. So let's just write that down to refresh our memory. The slope, which is denoted with the letter m, equals y2 minus y1 over x2 minus x1. Okay, that's the slope formula. You also need to know the distance formula, and we've done these already, but the distance formula, remember, usually with the little lowercase d. Subtract the x's. Square it. Subtract the y's. Square it. And it's all under the square root. Okay, so we're going to use these two formulas in the lesson, so you should memorize them. Another thing you have to know, we've done this already this year as well, is that parallel lines have the same slope. They never intersect, so they have the same slope. So if you look right here, let's see, this line has a slope of, looks like this line has a slope of 2/3. And this line right here also has a slope of 2/3. Okay, so parallel lines have the same slope. And then perpendicular lines, which are lines that intersect to form right angles, have slopes that are opposite reciprocals. Okay. So for example, this line has a slope of -4, and this line has a slope of 1/4. Okay. Those are opposite reciprocals. Okay. For another example would be like 2/3 and -3/2, okay? Or 1/7 and -7/1, okay? Opposite reciprocal slopes. Those are perpendicular lines. Okay. Now we're going to do 4 types of problems today, okay? The first problem you might be asked about is proving a parallelogram. So for these types of proofs, okay, there's 4 ways to do it, okay? And you don't have to prove all of these, because if you did, you'd be here all day long, okay? You only have to prove one of them, okay? You may prove any of the following, okay? Any one you want, okay? You can prove that both pairs of opposite sides are parallel, or you can prove that both pairs of opposite sides are congruent, or you can prove that one pair of opposite sides is both parallel and congruent, or you can prove that the diagonals bisect each other. Okay? I would say number 4 is the hardest way, so I would not do it that way. I would do one of the top 3. I'd say probably the first one is the easiest. Okay, but this one I'd say 1, 2, and 3. Those are all about the same difficulty level. Number 4 is the hardest one to prove. So if you ever have to prove a parallelogram, you can choose any of these 4. To prove that a quadrilateral is a rectangle, you may prove any of the following. You can prove that all 4 angles are right angles. I'm going to say that's the easiest way. Or you can prove it's a parallelogram with congruent diagonals. So that one is longer because first you have to prove that it's a parallelogram. So first you have to show one of these 4 things. And then you have to show that the diagonals are congruent. So that's why I think the top way is the easiest one for that one. Okay. To prove that a quadrilateral is a rhombus, you may prove any of the following. Okay. You may prove that all 4 sides are congruent. And I'm going to say I think that's the easiest way. Or you can prove it's a parallelogram with perpendicular diagonals, okay? Now, that way is longer because first you have to prove it's a parallelogram using one of these four methods up top. Just like with rectangles, you have to do that, that second choice. And then you have to prove that the diagonals are perpendicular, okay? So I would say the top way is the easiest way for that one. And finally, the last one is proving squares. Now, this is the longest one because there's a lot of requirements, okay? It's basically like you're proving a rectangle and a rhombus all in one, okay? So you have to prove that you have all four right angles, all four angles are right angles, and all four sides are congruent. I'm going to say that's the easiest way. The other option is to first prove you have a parallelogram, and then prove that the diagonals are congruent, and then prove the diagonals are perpendicular. So again, I think this top way is the easiest one. Okay. Now we're going to do one example of each. And I'm going to go in order. First, we're going to prove a parallelogram. Then we're going to prove a rectangle. Then we're going to prove a rhombus. Then we're going to prove a square. So we're going to do one of each. Okay. Example 1. Prove or disprove. So it might not actually be true. Okay. Prove or disprove that quadrilateral ABCD is a parallelogram. Okay. So, I mean, it's probably obvious what you're going to do first. You should probably graph it first. So let's do that. A is 4, 4. B is 3, 1. C is -2, -1. And D is -1, 2. Let me connect those. I'm going to label those. Okay. So then these are called coordinate proofs. Make sure you label the vertices because it's going to come in handy when you do the actual proof in a minute. So this was A. That was B. This one was C. This one was D. Okay. So again, back in the previous page, in order to prove a quadrilateral is a parallelogram, you have to prove one of these four, any of these four that you want. You pick whichever one you want. Okay. Again, number 4 is the hardest one. I would not do that. One of the top 3. I'm going to do the top one. I'm going to try to prove that both pairs of opposite sides are parallel. So how do you prove that the opposite sides are parallel? You prove that they have the same slope. So that's how I'm going to start this problem. Okay, I'm going to get the slope of all four sides. Now you cannot just count. Okay, you cannot just count. Okay, because it's a proof, and that's not good enough. You have to actually show out your work. Okay, so I'm going to start by getting the slope of segment AD. I'll write that down here. Let's get the slope of AD. M equals y2 minus y1 over x2 minus x1. Okay, that formula is on the first page. Okay, subtract the y's and subtract the x's. So I'll do 4 minus 2. Over 4 minus -1. Whenever you subtract a negative, you can make that plus a positive. So it's going to give me 2 over 5. Very good. Now let's get the slope of BC. I'll do 1 minus -1 over 3 minus -2. Make them both plus positives. So 2 over 5. Okay, excellent. We're halfway there. Not bad, actually. Okay. So those two sides, those are opposite sides, and they have the same slope, so that means they're parallel. Now let's do the other two sides. Let's do side AB. Okay. So the slope of AB. You know what? I'm going to go back to the last page. I think this is definitely the easiest one, so I'm just going to write down right here. This is the easiest one in my mind, so I'm just going to label that like we did before. I think that number 1 is definitely the easiest way to prove a parallelogram. I think 2 and 3 are the next easiest ones, and then number 4 is definitely the hardest one. But I think 1 is the easiest. Anyway, back to the slope of AB. So it's going to be 4 minus 1 over 4 minus 3. It's going to be 3 over 1. Which is just 3. Now remember, this slope is not the same as these two, okay? The opposite side should have the same slopes. So we just did the slope of AB. Now let's do the slope of CD, the last one. Slope of CD. So I'll do 2 minus -1. Over -1 minus -2. Okay, just be careful for the signs. Whenever you subtract a negative, you can make that plus a positive. Plus a positive. That's going to give you 3 over 1. Which you would then simplify to just 3. So we've shown that both pairs of opposite sides have the same slope. That means that both pairs of opposite sides are parallel. So the answer is going to be yes. I mean, I'm going to write my answer. I'm going to just put it in a sentence so it looks good. So the question said, prove or disprove that ABCD is a parallelogram. So I'm going to say ABCD is a parallelogram because, I'll say ABCD is a parallelogram because both pairs of opposite sides are parallel since they have the same slope. That sounds good. Both pairs of opposite sides are parallel since they have the same slope. You can probably stop after you say ABCD is a parallelogram because both pairs of opposite sides are parallel. That's probably good enough, but I just added on since they have the same slope. Okay. Let's try example 2 now. Again, I have 4 examples today. Example 2, prove or disprove that quadrilateral STUV is a rectangle. Okay, so let's start by graphing that. -4, 0. -2, 4. And 4, 1. Okay. Make sure you label the vertices. So this was S. was T, U, this was V. Okay. Prove or disprove that it's a rectangle. So it might not be a rectangle, remember. Prove or disprove. So I'm going to use this method. I'm going to prove that all four angles are right angles. How do you prove that they're right angles? You prove that their slopes are opposite reciprocals. Okay? So I'm going to find the slope of all four sides. I'm going to see if we have opposite reciprocal slopes. Okay? Let's start with UV, I guess. Let's start with UV. Do it over here. Slope of UV. Wait 1 second. Okay, so for the slope of UV, I'll do 1 minus 4 over 4 minus negative 2. Make the negative minus negative plus a positive. So it'll be 3 over 6, which is a negative 3 over 6. We'll just simplify that to negative 1/2. And remember, we got to get the slope of all four sides. So I'll move on to VS next. Let's do VS. I'll do 1 minus negative 3 over 4 minus 2. One minus negative 3 over 4 minus 2. Plus a positive. So 4 over 2. Which equals 2. Now, let's look at what we got, okay? UV is negative 1/2. VS is 2. These are opposite reciprocals. See, negative 1/2 and positive 2. So that means these are perpendicular. UV and VS is perpendicular. I'm going to go and label that as a right angle. I'll do it right now. Okay, we just proved we have one right angle right there. But we got to prove that we had 4, so we have to keep going. Now let's move on to the slope of TS. So do 0 minus negative 3 over negative 4 minus 2. Plus a positive. 3 over negative 6. Simplify that to negative 1/2. Now notice that these are opposite reciprocals, 2 and negative 1/2. So since these are opposite reciprocals, it means that they're perpendicular. So VS and TS are perpendicular. So let's add in that right angle right there. Excellent, excellent. Now let's keep going. Let's do the slope of, we still have to do slope of UT. Slope of TU, I'll say. Doesn't matter. So slope of TU. I'll do 4 minus 0 divided by negative 2 minus negative 4. Make that plus a positive, and you have 4 over 2, which equals 2. Now notice that these two are opposite reciprocals, so these are perpendicular. So TS and UT form a right angle. And now, so I just drew that one right there. And now if you look for angle U, TU and UV, going to be these two. And these are also opposite reciprocals. So we have another right angle. Okay. So all four are right angles. So it means yes, it is a rectangle. I'm going to say STUV is a rectangle because it is a quadrilateral with four right angles. I think that's probably good enough. I'll stop there. Okay, 2 examples down, 2 examples left. Example 3, prove or disprove that Jklm is a rhombus. Okay, so let's graph it first again. Negative 3, 2, 1, 3, 2, 7, negative 2, 6. Okay. Connect those and label the vertices. J, K, L, M. Okay. How do we prove we have a rhombus? We're going to prove that all 4 sides are congruent. That's the easiest way. How do we prove that the sides are congruent? Use the distance formula. Okay. So here we go. Let's start with, I'll start with JM. Let's do the distance formula at JM. Subtract the x's. So do negative 3 minus negative 2. Squared. Plus, subtract the y's. 2 minus 6 squared. All under the square root. Now you have to go slow and be careful for your signs. Okay, remember, minus a negative, you can just make plus a positive. So it's going to be negative 3 plus 2 is negative 1. Negative 1 squared is 1. Two minus 6 is negative 4, and negative 4 squared is 16. That gives you the square root of 17. Yes, you must show out these steps because this is like a proof, kind of. So you have to show out your work. This is your proof right here. Okay. So JM equals the square root of 17. I'm not going to make that a decimal. I'm just going to leave it as a square root. Okay. And you cannot simplify the square root of 17. Okay. Now let's move on to ML. I'm just going to go in order. Let's go to ML. I did JM. Now let's do ML. Two minus negative 2 squared. Plus 7 minus 6 squared. You can make this plus a positive if you want. So that's going to be 2 plus 2 is 4, and 4 squared is 16. Seven minus 6 is 1, and then 1 squared is 1. So 16 plus 1 is 17. Excellent, excellent so far. Now we're halfway done. Now we have to do the two other sides and see if they come in the same distance. Let's move on to LK. I'll do 2 minus 1 squared plus 7 minus 3 squared. Two minus 1 is 1. 1 squared is 1. 7 minus 3 is 4. 4 squared is 16. So again, you get the square root of 17. And that leaves JK or KJ. Doesn't matter. I'll do 1 minus negative 3 squared plus 3 minus 2 squared. Make that plus a positive. So 4 squared is 16, plus 1 squared is 1. So 16 plus 1, which is square root of 17. And as you can see, all 4 sides have the same length. So it means that all 4 sides are congruent. So yes, it is a rhombus. So I'm going to say Jklm is a rhombus because it is a quadrilateral with 4 congruent sides. That's probably good enough. You can say because the distance formula shows that, but I'm not going to write that. All the work is above. 4 congruent sides. Okay. So that's 3 examples down, 1 example left, which is the longest one, a square. Okay, because a square you basically have to do a rhombus and a rectangle combined. Okay, prove or disprove that WXYZ is a square. Let's graph it first. Okay. Connect and label your vertices. This is W. This is X, Y, and then Z. Okay, now for a square, to show that all 4 angles are right angles and all 4 sides are congruent. So you have to show 8 things. Now remember, if something doesn't work, then you can just stop the problem and say, no, it's not a square. Okay? But this one is going to work, so you're going to have to do all the work. Okay? Okay. Let's start with the slopes, because I think that's the easiest one. Let's get the slope of all four sides. Start with a ZW. I'll go a little faster because we've done this a lot. ZW, slope equals. I'll do 4 minus 2 over 2 minus -3. Plus a positive, so it'll be 2/5. Now let's do the slope of WX. Four minus -1. Over 2 minus 4. Plus a positive. 5 over -2, so -5/2. So as you can see, these are opposite reciprocals, so these are perpendicular. Now let's do XY. -1 minus -3 over 4 minus -1. Plus a positive, plus a positive. Slope equals 2/5. So you can see these are opposite reciprocals, so these are perpendicular. Another right angle right there. Now let's do the slope of YZ. -3 minus 2 over -1 minus -3. Plus a positive. -5 over 2. Therefore, we have 4 right angles, because now we have a right angle here, and we have a right angle there. Now, so we've proven it's a rectangle. Now to prove it's a rhombus as well, which will make it a square in the end. Let's get the distance of all 4 sides. I'll start with WZ. I'll go a little faster because we've done this already. Two minus -3 squared over 4 minus 2 squared. Make this plus a positive. 5 squared is 25. Four minus 2 is 2. 2 squared is 4. 25 plus 4 is square root of 29. Let's check all 4 sides. Let's do WX next. Two minus 4 squared plus 4 minus -1 squared. Make that plus a positive. Okay. 2 minus 4 is -2. -2 squared is 4. Plus 25. Because 5 squared is 25. So that equals square root of 29. Suppose you got square root of 29, you got square root of 50. Then you can say the answer is no. You don't have to keep going. But so far, so good. Let's do XY next. Four minus -1 squared plus -1 minus -3 squared. Plus a positive, plus a positive. 5 squared is 25. -1 plus 3 is 2. 2 squared is 4. So again, we have the square root of 29. WZ, WX, XY. Now we have to do YZ. -1 minus -3 squared. Plus -3 minus 2 squared. Make that plus a positive. 2 squared is 4. Plus -5 squared is 25. So it'll be square root of 29. And as you can see, all 4 sides are congruent. And we have all 4 angles being right angles. So yes, it is a square. So I will say WXYZ is a square because it is a quadrilateral with 4 right angles and 4 congruent sides. And that is the end of that lesson. Okay, that lesson was called Coordinate Proofs. If you watched the entire thing, then shout out to you.